Yes, so we're still dealing with this question for TBL PLC. We're on part B. They're saying assume TBL PLC has a share value of 1.27 x div and has recently paid a dividend of 8 ngwe per share. The dividend growth is expected to be approximately 3% per annum into the foreseeable future. Both preference shares and debentures are redeemable at par in 5 years' time. Calculate the Wacc using the market values as weighting factors. Okay, so here we already tabulated the weighting factors for ordinary shares, preference shares, and the debentures. Here's just a recap. Okay. I believe, do we remember how to find the market values of ordinary shares, preference shares, and debentures? Do you remember how to calculate those market values, colleagues? Mm-hmm. Mm-hmm. Yes. For preference shares, sure. Forgotten for preference shares. colleagues. Ah, yes, sir, continue. Or first, before you answer, sir, did all of you watch the video which was posted? Okay. Yeah. Mm-mm. Yeah. Yes. Okay, our advice, even after this class, as tomorrow or any other day from now on, watch the previous video, okay, and also attempt the question so that when we start doing these questions here in class, you are not lost, okay? Because here I'm now fearing that once I just start the explanations, everyone will just get lost automatically. So hang into the explanations, and I'll advise you watch the previous video. So ordinary shares, preference shares, and debentures, the market values are calculated in the same way. Okay. So for ordinary shares, we say it's the number of ordinary shares multiplied by the market price. For preference shares, we said it's the number of preference shares times the market price. So for debentures, what will we say? If ordinary shares is number of ordinary shares, debenture preference shares is number of preference shares times market price. Debentures, what will we say? Madam, mute your mic. Yes, colleagues, we're not seeing the pattern here. For preference shares, number of preference shares times the market price. So for debentures, what do you think it will be? Follow this sequence. Look at how we did for ordinary shares and preference shares. So for the number of debentures times market price. Have you seen the pattern that's here? Yes. So for ordinary shares, to get the number of ordinary shares, is the ordinary share capital divided by the par value of the shares. Par value or book value or face value or nominal value. Okay. That's how you get the number of ordinary shares. So, what if it's like that for ordinary shares? Can someone tell us how it would be for preference shares? To get the number of preference shares, what do we do? What are we dividing? What? Yes. What do we divide by the par value? Mm-mm-mm. Mm-mm-mm. That's not my question. I'm saying what do we divide by the par value to get a number of preference shares? Look at the example above and try to apply it to this one here. Look at for ordinary shares, we said ordinary share capital divided by par value. So for preference shares, what would be on the number? Yes. Preference share capital. Yes. So for debentures, how will it be? Okay. Yes, you can just say the debenture value. Okay, because remember, preference shares and ordinary shares, these are the part of the equity, which is also called capital. Okay. Now debentures are not part of capital. Okay, they are debt. But you just said debenture value or value of bond. Okay. But in your context, Mr. Austin, you are correct, right? Because basically what you meant is the debenture value divided by the par value of the debentures. Par value, um, face value, nominal value. Yeah. So colleagues, because in the exam, this is not going to be given to you. And it's not all the time they'll give you the number of these things, number of preference shares, number of whatever. So, any questions? Have we seen they're all following a similar format? Okay. To get their market values, you just get the number of these securities and multiply by the market price. To get the number of these securities, because these are called securities, shares, preference shares, debentures, these are securities. So the number of debentures, there's the debenture value on the balance sheet divided by the par value. Okay. Even ordinary share capital and preference share capital, these values down the balance sheet. So we got our market values. Okay, for ordinary shares, 34,400, preference shares 49, debentures 7,800. And we already got their weightages. Okay. I hope colleagues will remember how to get these weightages. How do we get the weightages? How do we get these weightages? Mm-hmm. The total market value. Mm-hmm. Mm-hmm. Yes. Then you have skipped one part. Because after we add, once we get the total value, okay, once we add them, then now how do we get the weightage for each component here? Ordinary shares, preference shares, and debentures. You're on the correct path, Sam. I just want you to, yes. Okay, let's just correct it there. You get the total, listen, you get the total market value, okay, of all these components of financing. Okay, 47,100. You get the total. Then each of these components, you're going to represent them as a fraction or a decimal or a percentage. And how do we represent them as a fraction and a decimal? There's no par value being used here. There's no par value. Remember here, each component you divide it by the total. So for equity, which is 34,400, divided by the total market value, 47,100. Like here. Preference shares, it's 4,900. To get the weightage, you just divide it by the total value, 47,100. So for debentures, how will we get it? How will we get the weightage for the debentures? And which values are those? 7,800. Colleagues, are we clear? This is the time to ask questions. Adult learning, huh? And these lecturers want to make life difficult. Huh? So that's what you do, colleagues. This is the time to ask questions because remember, exams are approaching. We don't want to be where in July you are still reviewing work. Mm. So now we've got the weightages, okay? Because remember, part B, we have to calculate the work, the weighted average cost of capital. Okay, the conditions have now changed. Okay, so as I said, for the weightages, they'll still stay the same. What is going to change is how we're calculating our cost of equity, cost of debt, and cost of preference shares. Now, last time, as I said, if you hear the mention equity beta, just know you're using the capital asset pricing model. Now, if they mention anything about a dividend being paid, like here, and the growth rate of a dividend, you use the dividend valuation growth model. Okay, so with the dividend valuation growth model, this is the formula: cost of equity equals the dividend that has been paid, the current dividend paid, that is DO, in brackets 1 plus the growth rate divided by the market price plus the growth rate. Okay. That's if you hear a mention of dividends being paid and a growth rate, then you know that you're using the dividend valuation growth model. Okay. But if you hear equity beta, expected market returns, they rarely say risk-free rate. Okay. So yes, I was kicked off by network. As I was explaining, how you tell what formula to use for cost of equity. If they mention equity beta, expected market returns, or if they mention anything about government bonds or treasury bills, then you know you're using the capital asset pricing model. But if they mention about dividends, we just say the word dividend, basics. And you see also a growth rate for this dividend, then you know You're using the dividend valuation growth model. Okay. Yes. So this is the formula. This formula, I would don't want to say that they give it to you. You don't. Sometimes I don't think. I'll check. I'll check in the past papers. Or if anyone has seen a past paper, check. Okay, if this formula is given. Okay. So DO represents the dividend that has been paid. Okay. So this is 8 ngwe. So how do we convert this into kwacha? Because we're dealing with kwachas here. So 8 ngwe, how do we convert it to kwacha? Mhm. So we divide by 100. 8 divided by 100, that is 0.08 kwacha. So this is your DO. Okay. Then our market price 1.27. So PO equals 1.27. G, our growth rate 3%, 3% in decimal 0.03. Yeah. Okay. Market price PO market price. Well, let me write this formula in simple English. DO is the dividend paid, current dividend. Okay, open brackets, 1 plus the growth rate divided by the market price plus the growth rate. So you substitute 0.08, 0.03, 1.27. You add what's in the brackets, 1.03, multiplied by 0.08, then you divide it by 1.27. That's how we got 0.0648. And finally, you add with this 0.03, you get 0.0948. So when you convert it into a percentage, it's 9.48%. That's the cost of equity. That's the dividend valuation model. Any questions? Yes. Yes. Better you use the other method. Yes, you use this one. This one. For preference shares, okay, remember when they're irredeemable, we use this simple formula. Now here, they're redeemable in 5 years' time. So we are using this formula here. Okay, DO basically is the dividend for the preference shares plus the face value minus the market value. Let me put market price so that we're using the market price for this. As minus the market price divided by n over the face value plus market price divided by 2. So for the preference shares, remember we calculated the dividend. Okay, they are 9%. So you get 9% of 1 kwacha. So the dividend is 9 ngwe, 0.09 kwacha. That's the dividend. Face value or nominal value is 1 kwacha here. Market price, this is 0.98 kwacha. Okay, so you just need 3 figures: the dividend for the preference shares, the market price for each share, and the nominal value, the par value for each share. And you just substitute. Okay, so you solve each fraction independently. The top fraction 1 minus 0.98, 0.02, 0.02 divided by 5, 0.04. At the bottom here, 1 plus 0.98, 1.98, 1.98 divided by 2, get 0.99. 0.04 plus 0.09, 0.13 divided by 0.99, get 0.131, which becomes 13.1%. Oh, n is the number of years. All right. So it said these preference shares matures in 5 years. That's why we used n. N equals 5. Okay, colleagues. Any questions? For cost of debentures, when the debentures are redeemable, you use the internal rate of return technique. Okay. First thing you need to do is you need to tabulate the interest payments that will be given when this debt is purchased. Okay. So to get the interest payment, basically this is the after tax. It's the interest rate times the par value multiplied by 1 minus t. So for the debt, the interest rate was what? 10%. The par value, 1 kwacha. Market price, 1.04 kwacha. So get 10% of 1 kwacha, that is 0.1 kwacha. Then here, 1 minus T is the tax rate. So the tax rate, 30%. Said 1 minus 0.3, that is this 0.7 here. So this 0.7 times 0.1, that is 7, basically 7 ingwe, or 0.07 kwacha. This is how much interest you'll be receiving when you purchase this bond, okay? Once you found out the interest payments, okay, it's like, as I said, it's the same way we're doing the internal rate of return, okay? First, you get the first net present value, then afterwards you get another net present value. That's the internal rate of return. So, if you remember how we were calculating our net present value, we had cash flows, with our discount factors, and our present values. Okay, the only difference is here is we have an annuity. These interest payments represent an annuity. Okay, so instead of doing year 1 0.07, year 2 0.07, year 3 0.07, we can calculate the annuity. Okay, it's an annuity, so yeah, that's how it will be treated. Okay, so the way these debts operate, colleagues, this is the story of how they operate. In year 0, which represents year 1, the first day of year 1, you buy this debenture, 1 kwacha fongwe. That's why it's written as negative 1.04. Negative to represent you've paid out money. So after you pay this 1 kwacha fongwe, starting from end of year 1, end of year 2, end of year 3, end of year 4, end of year 5, you'll be receiving 7 ngwe. Okay? From year 1 to year 5, you will receive interest payments of 7 ngwe. Then, since this debenture matures in 5 years, so on the 5th year, after you receive your final interest payment, you also be paid the amount, the par value basic, this 1 kwacha. You also be paid the 1 kwacha. Okay, that's how these debts operate. You buy it, you'll be receiving interest payments. Then when the debt matures, you receive your final interest payment, and whatever amount is printed on whatever amount is the par value. Okay. So for this debenture, the par value is 1 kwacha. Are we okay with that, colleagues? Any questions? Yes, I hope you remember the internal rate of return technique. This is the same thing. It's just that you have got an annuity here, these interest payments. So you get your discount factors. Okay. So basically what's happening here is these monies which we're talking about, these interest payments and the money will be paid when the debenture matures. It's in the future. Okay. It's in the future. So basically, you want to convert them into today's value. Okay. So for year zero, remember, you just remember this formula: present value equals future value 1 plus r the power negative t. Okay. Now these are for one-off payments. Okay, that's why this one is only going to be used in year zero and year five. Okay. Our discount rate is 10%. The discount rate, always use the interest rate for the debt. Okay, that's what you're going to use as a discount rate. The interest rate for the debt. So this 10%, which we are using as our discount rate, is from the interest rate for the debentures. For an annuity, remember the formula for annuity is 1 minus 1, 1 minus open brackets, 1 plus r close brackets to the power negative t divided by r. Okay, that's how you get the discount factor for an annuity. So here our r is 10%, so it's 0.1. When you do your tabulations here, you do your tabulations there, you're supposed to get 3.8 here. Here, for year 5, 1.1 to the power negative 5, 0.621. Then to get the present values, you're just multiplying these two numbers. Negative 1.04, negative 1.04 times 1, 0.07 times 3.8, 1 times 0.621. Okay, just multiplying these two numbers to get your present values. When you get your present values, you add them up. Okay, so here we got negative 0.153. Any questions? So remember the internal rate of return technique, you need two present values, one negative, one positive. So colleagues, if your first net present value is negative, what are you supposed to do to the discount factor? Those who remember our lesson on when we're doing net present value and the internal rate of return, mhm, we reduce the yes. So if your first net present value, is negative, reduce your discount factor so that you can get a positive net present value. And if your first net present value is positive, then it means you have to increase your discount factor. So it's up to you to choose what figures you need. In the exam, be as extreme as possible. What I mean is, for example, here, since we use 10%, what a negative net present value. So I'll reduce to 2% or 1%. Okay, because if I start trying 9%, 8%, you might find that's time being wasted in the exam. So just be extravagant and go to extremes at least. If they say if we had to increase our discount factor from 10%, I would start with 20% as the next discount factor or 30%, because then I'll be sure that I'll get a negative net present value. So we repeat the process again. Okay. You get your new discount factors with your new discount rate of 2%. Okay. Using this formula for year 0 and year 5, 1 plus r to the power negative t. That's for year 0 and year 5. Then from year 1 to 5, use the annuity formula. 1 minus open brackets 1 plus r close brackets the power negative t divided by r. So when you do these tabulations, our new discount factor is 4.75%. In year 5, 1.02 to the power negative 5 gets 0.905. And then, yes, then you multiply again. Each cash flow, multiply it with the discount factors. You get your present values. When you get your present values, you add up. You've got now a positive net present value. Then to get your cost of debt, which is the same as the IRR in this case, this formula is given to you, but you have to remember what it says. Okay, 8% lower discount rate. Other times it will be presented as L. So if you see the L, lower discount rate. Others will show it as L% lower discount rate. NPV 8% or NPVL or NPVL percent means the net present value with the lower discount rate. So in this case, the net present value with the lower discount rate is 0.195. That is our NPVA. Then NPVB or NPVH is the net present value with a higher discount rate. In this case, negative 0.13. Okay. So from this table, these are the four factors that you need. The net present value with the higher discount rate and the one with the lower discount rate, and then the individual discount rates. So B% or L% or H% or H is the higher discount rate. 2% or L% or L is the lower discount rate. So you're just getting four values from the table and you substitute into your formula, as you can see here. And you just working them on parts. You start with this one in the brackets, 10 minus 2, 8%. This fraction, you also deal with it. Remember, negative and negative make positive, so you add the denominators. Then you divide the fraction. Whatever value you get multiplied by the percentage, then at the end, add it. That's how we get 6.48%. So for this formula, as complicated it might look, just remember it just needs four things from the table. Net present value with the lower discount rate and NPV with high discount rate. And the actual lower discount rate and the higher discount rate. Once you have that, you put them in the formula. So once we've got our cost of debt, cost of equity, and cost of preference shares, we come back to our formula for Wacc. Okay. Last time I presented to you as E plus O plus P plus D. This is the other way they can be presented to you. Okay. VE is just for the value of ordinary shares. VP, value of preference shares. VD, value of debentures. Okay, same thing. If you are comfortable with the other ones, you can just use O, which is ordinary shares, P, preference shares, D, debentures. So we already had our weightages. Ordinary shares, this weightage, we did it, we got 0.73. Preference shares, with this weightage, we already did it, we got 0.014. 104. Debentures, this weightage, we did it, we got 0.166. Multiplied by each of their costs. Okay. 0.73 times 9.48, 6.92. 0.014 times 13.1, 1.36. 0.166 times 6.48, 1.075. You add all these three together, you get your weighted average cost of capital, which is the overall cost of financing for your business, or the minimum return required by the providers of finance.